Problem 8. A line of slope 1 intersects the parabola y squared equals 2px with p greater than or equal to 0 at 2 points A and B above the x-axis. Let k1 and k2 be slopes of lines OA and OB. Here O equals the point 0, 0. What is the range of all possible values of k1 plus k2? So first, what we do is we draw a graph. So let's draw the graph. So this is the parabola, and then there's a line that intersects the parabola at 2 points above the x-axis, and it has slope 1. So this is P1, suppose, and suppose this is P2. And then these lines, I'm going to draw the blue one as K1. The blue one has slope K1, and then the green one has slope K2. And then, well, let's suppose the y-coordinate of P1 is y1, and then suppose the y-coordinate of P2 is y2. So the problem says y squared equals 2px. So since they're both on the parabola, we can rearrange this as x equals y squared over 2p. So that means the x-coordinate of P1 is y1 squared over 2p, and then for P2, it's y2 squared over 2p. So we know that P1, P2, this line, has a slope of 1. And we also know how to find the slope using these variables. So let's do that. So the slope is equal to 1, but the slope is also equal to y2 minus y1, the change in y's, over the change in x, y2 squared over 2p minus y1 squared over 2p. That's equal to y2 minus y1. You can combine these two p's and the fraction to get y2 squared minus y1 squared over 2p. And then, since 2p is on the denominator of a fraction that's on the denominator of a fraction, that just basically, it reverses 2p goes to 1 over 2p, but then after that, being on the denominator of that fraction reverses it back to 2p. So this is actually equivalent to, this 2p at the denominator is equivalent to multiplying by 2p right there. And then there's a difference of squares at the bottom, at the denominator. So we can write it as y2 minus y1 over y2 minus y1 times y1 plus y2, then times 2p. So the y2 minus y1 on the denominator and numerator cancel. So we get 2p over y1 plus y2, and that's equal to 1. So that means 2p equals y1 plus y2. We're going to use this equation later. And then we also know that we also want to find k1 plus k2, or more specifically, the minimum and maximum values, because it asks for a range. But then the answer choices suggest that the maximum value is infinity. So let's not think about that for right now, because it's most likely kind of easy to find that out. But the minimum value seems hard, and it's also just the only difference between these four answer choices. It's the minimum value. So let's try to find that. So we know that k1 plus k2. So what is k1? K1 is the slope of the line from the origin 0, 0 to p1, which is y1 squared over 2p, y1. So the slope is just y1 minus 0, which is y1, and then over y1 squared over 2p minus 0, which is y1 squared over 2p. And then we can do the same thing for k2, just replace all the y1s with y2s. y2 squared over 2p. So the 2p's are in the same place as the 2p right there. So I can bring it up there. We can do that. And so that becomes 2p times y1 over y1 squared plus 2p times y2 over y2 squared. So then we can cancel out the y1 on the numerator and the denominator. And then same thing with y2. So we're left with 2p over y1 plus 2p over y2. So that's equal to, let's clear all of this. Just keep the final result of that equation. That would be equal to, if you add up the fractions, 2p times y1 plus y2 over y1, y2. And you do some factoring with the 2p and y1, y2. y1 plus y2. So we know from this equation that 2p is just equal to y1 plus y2. So we can replace this 2p with y1 plus y2, which would make this y1 plus y2 squared. So now we need to find the minimum value of that. And I'm going to make a bold claim that this is greater than or equal to 4 for any positive y1 times y1 and y2. Why? Because in these types of equations, it's good to make all the variables the same to see what result it attains. So if you make all the variables the same, so if you replace y1, y2 with y1, then you would get 4. And in most of these equations, that's like an extreme, either the biggest value or the smallest value. So let's see how we can prove this inequality. So let's first get rid of the fraction by multiplying both sides by y1 times y2. So we get this. And then after that, let's expand y1 plus y2 squared. So y1 squared plus 2y1 y2 plus y2 squared is greater than or equal to 4y1 y2. Then let's move all the variables to one side. So subtract 4y1 y2 from both sides. We get y1 squared minus 2y1 y2 plus y2 squared greater than or equal to 0. So now we can see that this is the square of y1 minus y2. So we're gonna use one of the most fundamental equations, inequality. So it says that all squares have to be greater than or equal to 0. That's quite trivial to prove, so this is true. So that means our original inequality is true. But if this was a proof contest, you need to prove this. You need to start with this and then go forwards all the way up to there. Yeah, so backwards you might do something that you shouldn't do, like for example square both sides when there's a minus on one side and a plus on the other, so that won't make sense. So that means the lower bound is 4. But this answer choice D suggests that it can't be exactly 4. It has to be greater. So why is that? Well, if you look back at the inequality, it says the equality only happens when y1 minus y2 squared is equal to 0. But then that would mean y1 equals y2. And why is that a problem? Well, let's see. If the y-coordinates of both points were equal, then they would be the same point, since they also have to be on the parabola. So they would both be right there. And it says in the problem, they are distinct points, or it implies that they are distinct points. So that means we can't have exactly 4, and we'll have something that is just a little above 4. So now let's make sense of the infinity, because that's a good thing to do even in non-proof contests. So why is the upper bound infinity? Well, let's clear all this. We don't need any algebra. And let's use the space to draw a graph. Again, this time we don't have to be really precise, because the only thing we need is intuition. So what if the line intersects at somewhere super low, like this? Then the slope would be super big. And that's k1. And then this k2 would still be a positive integer. So k1 plus k2 is gonna be super big. And if you just move this line closer and closer to the origin, it can never go on the origin or below, because that violates the conditions. But if you go just a little bit above it, then you'll see that this line basically goes to infinity, this slope. So that means the upper bound has to be infinity. So that means the answer would be 4, infinity. And Yeah, that would be the answer. Problem 9. What is the radius of the sphere that is tangent to all 8 edges of a regular pyramid with side length 2? Let's draw the pyramid. This is the pyramid. And let's consider the center of the sphere, somewhere here. The only way that it can be tangent is when the center of the sphere is the same distance from each of the 8 edges. But wait a minute. If we can show that there's symmetry in this figure, which it's obviously symmetric, then we only need to look at 2 of them actually. Which 2? These 2. And what else? There's actually another condition that you need to keep in mind. It's that it has to be right at the center. So, or more precisely, it has to be on the line where the center of the bottom square intersects with the top of the pyramid, or the apex. So let's look at this a little bit. There's certainly a bit of Pythagorean theorem right here. So the pyramid has side length 2, so this thing is half of it, or 1. So let's suppose this thing is 1 minus, let's calculate a bit more of its things. What is the length of this thing? It is, let's calculate it like this. So what I'm doing is I'm basically taking this triangle and then putting it on a 2-dimensional plane. So the diagonal has side length 2, and this is root 2. So this is also root 2. Yeah, so that's good. So if this thing is x down up there, this thing, then the bottom is root 2 minus x. And then what else? Well, we need to see that this thing, this is actually similar to this. So what is that telling us? Well, first let's prove that it's similar. Because this is a right angle and that is a right angle, then also these two share a common angle at the top. So they are similar. So let's make some equations now. Let this thing be y. So we can calculate y using the Pythagorean theorem. Y is equal to the square root of 1 plus root 2 minus x squared. And then this is also y because we want them to be equal, the distances. So that's also y. So we know that in similar triangles, the ratio, in this case, it's x to y. has to be the same as the corresponding ratio. In this case, it's this to this, or 2 to root 2. So x over y equals 2 over root 2. So that is root 2. So let's write this as x over root 2 equals y. So then we get x over root 2 is equal to this thing, and then we just square both sides to get x squared over 2 equals this. Well, the point is that the important point is it's a quadratic equation and you can solve it. So let's clear a bit of space. So we'll get this. And we multiply both sides by 2. Okay, so now what do we do? Let's just solve this equation. Wait a minute. Never mind, this isn't right, actually. Let's just do it again. So that's equal to x squared minus 2 root 2x plus 3. So yeah, this wasn't supposed to be 18. This was supposed to be 6. So now, let's do the quadratic formula. We'll get x equals 4 root 2 plus or minus square root of b squared 32 minus 4ac 24 over 2. And you'll get that's 4 root 2 plus minus 4 root 2 over plus minus 2 root 2. 2 root 2. So then this will either give you root 2 or it will give you 3 root 2. Which one is it? If x was root 2, then the center of the sphere would actually be right here. If x was 3 root 2, it would be all the way down here. Something like that. So is it up there or down there? Well, if it's down there, it obviously can't be tangent. But it could be something called like an x sphere in 3 dimensions. But it isn't tangent to the line segments, which is what we want. This is the in-sphere, something like that. I'm just making up words, I guess. So there it is. It's just, x is just root 2. So now what is y? I ruined my diagram a bit too much. But x over y is root 2 over y. 2. So y is obviously 1. So that's our answer. Problem 10. How many complex numbers z satisfy that z to the 2020 is equal to the conjugate of z squared? Here, the conjugate of z is the complex conjugate of z. Yeah. So let's look at this equation a bit. This is very weird. How are you supposed to get 2020 and all that? Well, it turns out that's what we want to know. The 2020. It's very weird. And let's think about what we can do to simplify it so that we don't have to go through all those cases. There are a lot of complex numbers. So how about something like we take the conjugate of both sides? No, even better, we take the magnitude of both sides. So the magnitude is equal to, they're equal to each other, but then using the magnitude properties, you'll get the magnitude of the conjugate is the same as its own magnitude. So you'll get this. So what possible values are there for magnitude z? Could be 0. It could be 1. But if it's between 0 and 1, magnitude z to the 2020 is way less than magnitude z squared. But then if it's bigger than 1, then magnitude of z to the 2020 is going to be way more than magnitude of z squared. So it's only 0 and 1. For magnitude z equals 0, then z equals 0. Z equals 0. For magnitude z equals 1, that would mean, what is the complex conjugate of something with a magnitude 1? That's kind of hard question. So magnitude conjugate, we have to use them. And there's a nice formula that allows you to use it. Z times z conjugate equals the magnitude of z squared. So in this case, z times z conjugate equals 1. So z conjugate equals 1 over z. So we can simplify this equation to z 2020 equals 1 over z squared. Or in other words, z to the 2022 equals 1. And if you know about roots of unity, then they have to be the 2022nd roots of unity. So there are a lot of them. There are 2022 of them. So there are 2022 roots of unity, and then there's one case z equals 0. So the answer is 2023. Problem 11. A, B, C, and D are positive integers that satisfy log base A of B is equal to 3/2 and log base C of D is equal to 5/4. If A minus C equals 9, what is B minus D? Okay, so let's first write them in exponents, which is what you should do whenever you have something that isn't that easy to describe in logarithms. So log A of B is equal to 3/2. It means A to the 3/2 equals B, or we can square both sides to get A cubed equals B squared. And then log C of D basically means C to the 5/4 is equal to D, or if you take the 4th power of both sides, you get C to the 5th equals CD to the 4th. So you want to find A minus C. So there's a lot of powers here, a lot of exponents. And there's also the intuitive fact that you shouldn't have exponents that are too close together. For example, it's not easy to find exponents such that like x to the fourth minus y cubed equals 5 or something like that. It might be impossible, actually. So let's try using that idea. So what power can A be? Could A be a perfect square, perfect cube, perfect fourth power? Let's see. So A cubed is equal to B squared. So A cubed is a perfect square. But then by prime factorization, A has to be also a perfect square. So A is something squared. And then C to the fifth is equal to D to the fourth. So C is equal to something to the fourth. So C has to be a perfect fourth power. So let's see how we can describe it. A equals, let's say, m squared, and C equals, in fact, we don't even need the fact that it's a fourth power only. We only need the fact that it's a square, because a fourth power is also a square. So C equals n squared. Then A minus C equals 9, or m squared minus n squared equals 9. So then m minus n times m plus n equals 9. So we can either have m minus n, m plus 1 be 1 and 9, or 3 and 3. For the 3 and 3 case, that would mean m equals 3 and n equals 0. But then the problem says n can't be 0 because we said C equals n squared, and C can't be 0 because it says A, B, C, D are positive integers. So it must be the first case. M minus n equals 1 and m plus n equals 9. Then m equals the average, which is 5, and then n equals 4. So A equals 25, and then C equals 16. And you see that C is indeed a fourth power. So it says to calculate B minus D. And we know that A cubed equals B squared. A cubed equals B squared. And A is 5 squared. So 5 squared cubed equals 5 to the 6th equals B squared. So then B equals 5 cubed, which is 125. So B equals 125. And then we also have C to the 5th is equal to D to the 4th. So C is 2 to the 4th. So 2 to the 4th to the 5th equals 2 to the 20th equals D to the 4th. So D equals 2 to the 5th equals 32. So then B minus D equals 125 minus 32, which is 93. So that's the answer. When a conical bottle rests on its base, the water in the bottle is 8 centimeters from its vertex. When the same conical bottle is turned upside down, the water level is 2 centimeters from its base. What is the height of the bottle? Okay, so I'm going to show you an important concept that I use to solve these kinds of problems. So whenever I do these kinds of problems, I think about first, these are similar, right? These are similar. And similarity in 3 dimensions means, for example, if two of its sides, suppose A over B, this is the first solid, one of the sides, and then B is the other solid's corresponding sides. If they're similar, then A over B is their ratio of sides, then A over B cubed is the ratio of their volumes. So that's not the important concept, that's just a formula, but the important concept is whenever you're trying to measure those things, you should compare it to the whole, the biggest thing that's similar. So it says 8 centimeters. So let's suppose the whole thing is K centimeters. So 8 centimeters over K centimeters cubed is equal to the volume, the ratio of the volumes of this versus this. So let's write that down. The ratio of the volumes of top vs all. But then what we want to know is this, and that's called the frustum. So top over all, let's think about what would happen if we took 1 minus that. Then that would be all minus top over all. But then since the whole thing minus the top part is just the frustum, this can be written as just the frustum. So that means 1 minus 8 over K cubed. That's the ratio between the volumes of the top versus the whole thing. That's equal to the frustum over the whole thing. Just write it as F over A. Yeah. And then the other picture, we see that there is a 2 centimeter gap probably. So this is again K, and this would be K minus 2. So now how do you calculate the area of the shaded region? So it's basically just K minus 2 over K, that's the corresponding side length, and then cubed. So K minus 2 over K cubed. And that's equal to the ratio of the shaded region over all. But then remember, the frustum is the shaded region in this picture. The frustum is the shaded region. So let's just write this as S over A. And then we can say 1 minus 8 over K cubed equals K minus 2 over K cubed. Okay, so let's clear up this space. And let's try to solve this equation. So we have 1 over this is 8 cubed 512 over k cubed. That's equal to k minus 2 cubed can be written as k cubed minus 6k plus 6k squared plus 8k plus 12k minus 8 after some expanding over k cubed. So then we multiply by k cubed on both sides and we get k cubed minus 512 equals k cubed minus 6k squared plus 12k minus 8. And then the good news is these k cubes cancel. So you're left with a quadratic equation, negative 6k squared plus 12k, and then plus 504 equals 0. So let's divide this equation by negative 6. So you get k squared minus 2k, and then 504 divided by negative 6 is negative 84. So that's equal to 0. So k is equal to, by the quadratic formula, 2 plus or minus the square root of 2 squared, which negative 2 squared, which is 4, minus 4 times 84 times 1. Negative minus 4 times negative 84 times 1. So it's plus 4 times 84, which is 336, and over 2. So we have to use the plus because the minus case will give a negative. So we're left with 1 plus the square root of 340 over 2. That's just root 85. So then that's k. So that's what we want, the height of the bottle. So we're done. Problem 13. M is a positive integer. X, Y, and Z are remainders of 63, 91, and 130 respectively when they are divided by M. If x plus y plus z equals 26, what is the sum of digits of M? Okay, so since there aren't any number theory things that we can do yet because of this equation, which is quite annoying, let's just try to get some equations, some more equations, use algebra. So we know that 63 equals an integer times m, so let's say p times m, plus x. And then 91, similarly 91 is q times m plus y, and then 130 equals r times m plus z. So to get an x plus y plus z, we can add those three equations up, and then we'll get the x plus y plus z. So 63 plus 91 plus 130, that's equal to 284. So 284 equals p plus q plus r times m plus x plus y plus z. So x plus y plus z equals 26. So we subtract 26 from both sides and we get 258 equals p plus q plus r times m. So that means m has to be a factor of 258. So 258 is 2 times 3 times 43. So m can be 2, but that's not likely because that would make x, y, and z very small. Or 3, that's also not likely. Or 6, that's still impossible. X, y, and z have to be less than or equal to 5, so the biggest you can get is 15. But how about 43? Let's try 43. So 63 divided by 43 has a remainder of 20. 91 divided by 43 has a remainder of 5. And 130 divided by 43 has a remainder of 1. So then you add that up, you get 26. So the answer is 43. Problem 14. Randomly choose 6 points A, B, C, D, E, and F on a circle. What is the probability that the triangles A, B, C, and D, E, F do not intersect? Okay. So here is the circle, and here are the points, and then first you should notice that it doesn't really matter which 6 points we choose as long as they're different, because if we chose something different, like for example this, the intersections would still be preserved as similar to like this. Even though they're different, the intersections would still be preserved. So let's draw a few triangles, right? We can have this triangle and then this triangle. Or those intersect. Or we can also have this triangle and this triangle. Those also intersect. Let's try to not make them intersect. Well, this time the only way to do it is to put one triangle on one side and the other one on the other side. So how many possibilities are there? Well, let's try to count them. The number of ways to choose A, B, C, D, E, and F so that ABC, the triangle ABC is on one side and the triangle DEF is on the other. So first, how about let's just divide it into how many cases there are to choose the triangles. And then let's arrange the points. So there are 6 triangles. Well, actually more like 3. It could be these triangle pairs or these triangle pairs or another one that I just drew. So there are 3 of them right now. And then we have to multiply that by how many ways there are to distribute A, B, C, D, E, and F. So there are 6 points, but we want to distribute A, B, and C on the same triangle. But we can choose, there are 2 triangles that we can choose for A, B, and C. So there are 2 choices. And then after we choose the triangles for A, B, and C, D, E, and F are also have to be on the other triangle. So there are another 3 factorial or 6 ways to order A, B, and C, and then another 6 ways, and then 6 ways to order D, E, and F. So we multiplied them all. And now let's find how many ways are there to just randomly select A, B, C, D, E, and F. So out of those, there are just 6 factorial ways, or 720. So 720. So this is equal to 3 times 2 is 6. 6 times 6 is 36 over 720. So we know that 36 over 720 is equal to 1 over 20. So we can replace that with 1 over 20. So 6 times 1 over 20. So 6 over 20, that simplifies down to 3 over 10.